Welcome to Analog Integrated Circuit Design lecture. This is lecture number 8 of Unit 2. And in today's class, we will start a technique called as gain boosting technique in order to improve the gain of the amplifiers or the operation amplifiers studied so far. Quickly looking at the previous lecture, it was lecture number 7, where we discussed about two-stage op-amp. By telling that there will be two stages and one stage will be dedicated for gain and another one for swing. And yeah, we derived the gain expression for this, and we also saw how we can configure a single-ended two-stage op-amp, and this is a fully differential two-stage op-amp. All right. So now coming to one, I think I told you the other day, a two-stage op-amp can be done fully differential even by including a telescopic op-amp as the first stage. That is what you are seeing on the screen. I asked you to draw this diagram. So here, this is your telescopic op-amp, which is fully differential. At the output, you have connected a CS amplifier, and if you write the gain expression, AV1 is the gain of the first stage, which will be same as telescopic. The approximated expression is what you are seeing now. And the second stage will have a gain of CS amplifier, and the combined gain will be AV1 into AV2, which will be the two-stage op-amp gain. All right. So now what we will do is we have to do one design of the two-stage op-amp that we will do soon after discussing gain boosting technique. So in today's class, we will see what a gain boosting technique is. If you compare, if you review the three amplifier stages we studied so far, one is telescopic, another one is folded cascode, and another one is two-stage op-amp. So you will naturally ask a question whether the gain obtained in such amplifiers are not sufficient. Is that why we are moving for gain boosting technique? Yes, the answer is yes. In gain boosting technique, we can increase the gain of the op-amp further, and we know that larger the open loop gain, it is good that we can have a better or a accurate closed loop response, closed loop gain. So that is why we are going for a gain boosting technique. Now, yeah, so the main idea behind this is we know that usually we will add transistors in a stack in order to improve gain. But here the idea is less number of transistors in stack, and thereby achieve high gain. That is the main idea. So previously we know how we do cascoding, adding one to the top of the other and thereby improving the gain. Here it is not by directly cascoding, but we are looking at some other different technique how we can improve the gain further. So let me start the discussion with the regular cascode. I think by this time this is very familiar. I am hoping that the circuit is very familiar for you. So say these are biased independently, then there are two transistors, and if I look at from this side R out, I can say that R out is GM1 R01 into R02. That is the cascode effect. Right. Now to increase gain further, we also saw that we can actually increase the number of transistors in the stack by just adding one more transistor, that we call it as triple cascode. So what you're seeing on the left side is double cascode, and if you add transistors further, we can say it is triple cascode. And if I load it with a idle current source, practically you cannot keep it like this. You have to add suitable number of transistors to the load side. So ideally, if I load with a with a current source like this, and if I number these as M3, M2 and M1, where this is the input transistor, and if these are some bias voltages VB1 and VB2, I can clearly write the gain expression of this as minus GM into R out, where GM can be approximated as GM1. If you apply the technique to find GM, you will get that, and R out will be equal to Aritra. Are you there, Aritra? Are you there, Aritra? All right, not there. Fine. Um, yeah, Anubha Mittal.
Yes, sir.
Yeah, Anubha, can you tell me what is the R out for this circuit? What you are
Uh,
seeing on the screen?
yes, sir, just a second. Okay, so R01, R02, GM R0, GM3, R03
Hmm.
into R02 into R01.
Okay, okay. Anu, is that right? Thank you, Anubha.
Sir, it's GA GM3 R03
Hmm.
R02 R01.
Okay. Anvai, is that correct?
It's not correct.
So he missed GM2.
All right. Yes. Yeah. So one GM2 you missed. So the R out expression is GM3 R03 GM2 R02 into R01. This is R out. So the gain expression, if you write here, gain can be written as if your GM and R outs are same, your gain can be written as GM R0 the whole cube. And this is what we call as a triple cascode amplifier. This we have, I think, yeah, we have discussed this before, triple cascode amplifier. So if I look at the practical situation, the idle current source should be replaced with a suitable number of transistors, that is actually 3, and thereby you will actually get the gain. You will get the gain actually GM R0 the whole cube, and suitably if you have the transistors to the top, those resistance will actually come in parallel, right? So why I have kept this triple cascode amplifier is just to say that if you add 3 transistors in stack, you will get a gain of GM R0 the whole cube. That is the idea of cascoding. Now, gain boosting techniques helps us to get almost the same gain of GM R0 the whole cube, but without adding 3 transistors in stack. So even though I have written the heading as gain boosting, what I have discussed is actually cascoding here. This is cascoding and this is triple cascoding. So cascoding means default it is double cascode, right? So now let me introduce what is this gain boosting technique. So how can I boost the gain? Not by adding 3 transistors in stack, but still we will get the effect of a triple cascode. So I'm just replacing the previous circuit of uh, triple cascode, but I am just using only 2 transistors in stack here, and I am numbering it as M2. Listen carefully, this is an important technique. Numbering it as M1 and M2, and this is my output terminal V out, and this is the idle current source of value I1, right? Now this is where I will provide the input as V in. Now gain boosting technique says that I can sense the signal from the source of this transistor M2, right? From this double cascode amplifier, because this the if I say double cascode, that is what you are familiar now. So from the source of the M2 transistor of the double cascode, you can sense that signal, and if you can give that signal back to the gate, not directly but by passing it through an amplifier in this fashion, where this amplifier should have some gain. I'm marking it as say a minus A. I'll write it properly. Yeah. So sends the signal from the source of transistor M2, feed that signal back to the gate through an amplifier which can provide a gain of minus A. Now can you tell me what will be the signal available at the gate if I have sensed the signal as Vs? Amitesh, are you there, Amitesh?
Yes, sir.
Yeah, Amitesh, can you tell me what is the signal at the gate of M2 now?
Sir, it will be amplified, no, sir.
Yeah,
By a
amplified.
factor,
So, right. So, can you tell me the in terms of the signal notation what I have marked on the diagram?
sir, it will be AVS. Is that correct,
AVS
sir?
or minus AVS?
Minus AVS, sir.
Yeah, it is minus AVS. Thank you, Amitesh. Yeah. So, it is minus A into VS. And now I will call this amplifier as, so I have an additional amplifier here, and I will call that amplifier as an auxiliary amplifier, because that is not the main amplifier. I have the main circuit here, but to the main circuit, so main circuit is drawn in red, and whatever I have drawn in blue, I am calling it as an auxiliary amplifier. And if I can provide, if I can sense the signal from the source and provide that signal back to the gate of M2 as minus AVS, This technique says that the gain measured of this circuit will be equal to Gm R naught the whole cube. This will be the gain measured of this circuit. All right. So how will I find that, or how will I say that the gain measured will be Gm into R naught the whole cube? For that, I have to find the output impedance of this circuit and Gm of the circuit separately. So what I will do is I will try to find the output impedance of the circuit. How will I find the output impedance of the circuit? I will replace the same circuit. Sorry, I will take a copy of the same circuit and I will place it here. And what I will do, I will uh, yeah, in order to find the output impedance, I just remove the load and I am connecting a source there whose value is Vx and which is giving a current of Ix. And I'll find the output impedance, and that output impedance multiplied by the gain, approximately it is small gm1 of the input transistor, can be kept as the voltage gain of this combined gain boost combined circuit. So when I say now my reference is the gain boosting, I have actually performed gain boosting on this red main circuit with an auxiliary amplifier. And what I have done with the auxiliary amplifier is from the source of M2, from the source of Cascode transistor, I have fed back to the gate through an amplifier. All right. So now my question to you guys is, you can see the second diagram what I have drawn on here on the left side down. Can you draw the equivalent circuit of this and find the output impedance? Draw the equivalent circuit and find the output impedance. Is it possible? So when I find the output impedance, I have to short the input. So what I will do is I'll delete this. I'll keep it to ground. Yeah. Now I need to find what is Vx by Ix. So how will I do that?
So I have a doubt. Will the
Yes.
A amplifier be just like a common source amplifier?
Yeah, so I'll talk about what A amplifier will be. As of now, keep it as a minus A. So since it is minus A, it should be in a simple form, it should be a common source amplifier. Yes.
Okay.
Yeah. So what will I do now? I'll look at the transistors M1 and M2 transistor. M1, you can see that gate and source are grounded. So the equivalent of the transistor will be a single resistance whose value will be R01, that is M1. All right. I'm finding the output impedance. So gate and source are now connected to ground. That is why I replace the transistor with its equivalent by removing the current source, only resistance there. Now for the second transistor on the top, I'll replace it with the current source because there is a VGS existence and the R0 of that transistor there. So which is R02. Now I need to see what is the GM VGS term here. What is a gate? Gate is having a potential of minus A into Vs, that is a gate potential. Now source is having Vs, then the current source can be written as Gm into gate potential is minus A into Vs and source potential is Vs. So I can write as Gm2 into minus A into Vs minus Vs. That will be the current source value. And I need to add this at the output side, which is Vx, and this current is Ix. Is this fine? Is this clear what I have drawn here? The equivalent circuit. The M1 transistor is replaced by resistance. Current source will not exist because the VGS is 0. Now the second transistor, which is M2, M2 is replaced by the current source and the resistance. I just neglected the body effect. And suitably marked the gate and source potential as minus AVS and VS, and based on that I have just named the current source value as GM2 into minus AVS minus VS. Right. Now what I need to find here is Vx by Ix. So first let me write what is Vs here. What is Vs? Vs can be written as Ix into R01 because Ix is the incoming current. Now, how will I write Ix here? What is Ix? Ix is the current. So I can write Ix as sum of two things. One is the current flowing through R02 and another one is the current of the current source. So how will I write the current flowing through R02, which is Vx minus Vs divided by R02, that is the current through R02, and the other one is the current which is flowing, which is a current source value. So I will write it as, I'll just take minus common, Gm2 common, A plus 1 into Vs. This is the current through, this is the current value of the current source, right? Now the only thing is you have to simplify this. You know what the value of Vs as Ix into R01, just substitute and simplify. So I'll ask you to do that. So this is Vx by R02 minus Ix R01 by R02 minus Gm2 into A plus 1 into Ix into R01, and now you have an equation where all the terms is either having Vx or Ix, so you can just take Vx by Ix, and if I do that I will get it as R01 plus R02 plus Gm2 R02 R01 after taking LCM into A plus 1. This will be the equation what you will get if you rearrange the terms properly. And from this I can say that the R out value is equal to, if I approximate this, so if I say that if I approximate this, I can write it equal to Gm2 R02 R01 into A. If A is large, say A is 10, 1 plus A can also be written as A. So this is the approximate output impedance of this circuit after employing the gain boosting technique, right? So I hope this is clear, but I see there is a question. Yes, Amitesh. Which part you are asking, Amitesh?
No, sir, I understand. Thank you,
All
sir.
right. Okay. Yeah. Okay. So what I will do is, now we have the output impedance R out we have calculated. Now, as I didn't see who asked what type of amplifier we will use. We will use a common source amplifier and say this is the auxiliary amplifier structure. Say this is the auxiliary amplifier structure where this is if I am giving Vs here, I will get minus A into Vs like this. All right. And assume that A value is equal to Gm into R0. Okay, let me name it. So in my original circuit, I have M1 and M2. So I have just drawn auxiliary amplifier as M3. And what is the input to the auxiliary amplifier? Input is Vs and output is minus A into Vs. Just to identify that, I have marked the same thing there. And I have written the gain as Gm3R03. This is for the auxiliary amplifier. Now, I will go back to my previous circuit. So what is my previous circuit? I have the circuit as a cascode amplifier where I have two transistors here in series. So this is V in, this is M1 and this is M2. Now I need to sense from the source of this M2, and that should go to the gate of the transistor M3. So I will replace that here. This is M3 and I should take output of this, and that output actually should go back to the gate. So this is the structure. All right, is this clear what I have drawn now? I have just replaced the triangle, the amplifier block with the circuit itself. So this is Vs, and if this is the gain of this is A, I can say that this is minus A into Vs. I don't think there will be a doubt on that. And this is the final output V out. Now, how will I write the gain expression for this? For this combined circuit, I know that R out expression is approximately what I have obtained in the previous page, which is equal to Gm2 R02 R01 into A, Gm2 R02 R01 into A. What is A? A is Gm3 R03. So I can say that it is Gm2 R02 R01 into Gm3 R03. Now, what is the voltage gain of the combined circuit, which is equal to Gm into R out? Again, by approximating capital Gm into small g1, if I substitute, I can say it is Gm2, Gm3 into R01, R02, R03. All are approximations. It is not the exact value what I have written. Or this can be equated to Gm into R0 the whole cube. All right. So what is the takeaway here? We obtain gain. In ideal case, we obtain the gain as Gm into R0 the whole cube by applying gain boosting. But before applying gain boosting, for a triple cascode also you will get the same gain, GMR not the whole cube. Now what is the difference between these two? If you look at these circuits carefully, in a triple cascode amplifier there are 3 transistors added in stack. So that will directly detect the supply, or that will directly affect the voltage headroom available. But in the case of this gain boosting technique, you can see that the number of transistors added in stack is only 2 on this side. All right. So in that way, I can say I can have lesser number of transistors on the stack, and still you can have a larger voltage gain, or the voltage gain as same as that of a triple cascode amplifier. So that is something called as gain boosting technique. Sensing the signal from the source of the cascode transistor, feed it back to the gate of the cascode transistor by amplifying it, and that will result in almost the same gain as that of a triple cascode amplifier without stacking 3 transistors on the in one stack, without stacking 3 transistors. So now you can see that whatever I have marked in green is the main amplifier, and whatever I have marked in this violet color is the auxiliary amplifier. So that is a general way how we will mark the main amplifier and auxiliary amplifier. This is auxiliary amplifier and this is the main amplifier. That means this technique can be extended to any amplifier we have studied so far. So if you have a telescopic op amp, you can do this gain boosting in telescopic op amp, and you can get a larger gain than the previous gain. Is that clear? Any doubts on this? Any doubts on this gain boosting technique? But sir, still yes, we are using 3 transistors, but not on the same stack. That is a catch.
So, excuse me, sir.
Yes.
So, what is the difference between doing this and using cascades, sir? Like, we use, I mean, instead of doing this, we can also give the output of the cascode structure to a common source. I mean, common drain.
Mm, to a common drain.
No, sorry, common source, sir.
Common source again. Yes, yeah. You can do that. So if you are comparing, or if you are looking with respect to the power consumption, yes, here we have 2 branches. We need to branch, like we need to have sufficient current for the 2 branches, which is yeah, I can say you can actually get the gain there if you directly cascade an amplifier, but your overall gain will be just the product of that, right?
Yes, sir. So, won't it be the same, sir? Like the gain?
Gain, you will have GM R naught the whole square into GM R naught. Yes, it is almost the same. Yes, very true.
And even the power will be same because 2 current source we are giving to the same BT.
Very true. So when we say about the power, yeah, power again we can decide. So how we want to have it. Like regarding power, if you want to split it equally, or if you want a different power, in that way definitely we can do that. Now the advantage of this will be seen when you apply this to a bigger circuit. I can show you one example, Aditya. I got your point. So for a very simple circuit, it looks like very like what to say. Like what is the need of this, we will think in that way, right? What is it like? You can directly add a circuit to the output. So let me show the circuit for you. All right, so can you see this? What I have done is for a telescopic op amp. Let me do one thing. Yeah, no, this is something what I want to discuss next. So before that, only you ask that. Yeah, so what I have done here is what you can see on the screen now is a telescopic op amp which is drawn in blue, and by simply giving a cascode amplifier from the gate to the what to say, simply connecting. One second, let me use this color. Yeah. So first, please focus. I'm just saying to everyone, please focus on to the blue colored circuit diagram. So M1 and M2 are the input transistors, you have other transistors like Cascode for the input. Let me number it as M3 and M4. Then you have M5 and M6 over here, and M7 and M8 is anyway on the top. Yes. Now, for this telescopic op amp, what you can do here is you can directly send the signal from the source of the cascode, feed it back to the gate on both sides. Can you see this? Similarly, sends the signal from the source of the cascode, feed it back to gate on both sides. So this is actually what you apply. This is what you can say that what we are applying gain boosting here directly to the telescopic op amp. So instead of getting the output of this, and then again you have to design another circuit, and then you have to look at the swing and other constraint, other things of that second amplifier again. So that becomes a regular two-stage op amp when you have that kind of structure as first stage, and when you are directly adding a CS amplifier, that becomes a two-stage op amp. This is something you have only one stage here. Within that stage, actually, you are including this technique. So if you ask me about the differences of two stage and single stage, then so regarding the location of the pole, the bandwidth, all those things will be affected when you have two stages. Stability will be affected when you have two separate stages. When I say affected, you have to work on the stability of the circuit. So when you have multiple stages, you have to look for the stability in a deeper way. Only that is the difference.
Okay,
Otherwise,
sir.
otherwise you have to, otherwise here also we have to have a separate current. We need to spend little, we need to burn some more power on the auxiliary amplifier part as well.
So this is more efficient.
Yeah, in certain aspects, yes.
Like it preserves the signal. I mean, there is no much loss because there's no two stage.
Yes, yeah. So, but because no, since we are not looking at the stability part now, with respect to stability, if you go with one stage op amp, that is one way it is better. But again, we cannot make a concluding remark without looking the location of the poles.
Okay, sir. Thank you, sir.
Yeah, thank you, Aditya. And one more thing, so what you are seeing on the left is by including different single stage, like I have included 4 amplifier stages in yellow as auxiliary amplifier. On the right hand side, what I have done is, since we are getting the signal from both the sides, I am just including a fully differential op amp. So you can think about a differential amplifier there, which is so from both the sides the signal will go to that, and the output will be gone to will be given to drain in a similar way. So you can employ two op amp, fully differential op amp itself as the gain boosting stage on the right hand side, which is the compact version of this gain boosting. All right, I hope this is clear, but here also we should actually identify all the stages. So this as the main amplifier, or this as the input pair, and this as the cascode for the input, this as the load devices, this as the cascode of load, and whatever we have drawn in yellow is the auxiliary amplifier, and whatever is there on the blue, the navy blue, is your main amplifier. All right.
So can we do something similar to single-ended or telescopic op amp?
I didn't get.
Like, can we add like a gain boosting stage in a single-ended telescopic op amp also?
Yeah, definitely we can do that. For single-ended amplifiers or for fully differential amplifiers, you can do that.
Okay, sir.
Yeah. All right. Now, yeah. So we'll quickly see one. One question of this. All right. So if you understand this question, that means you understood the previous amplifiers what we discussed so far. The question here is, calculate the output impedance at the drain of M3. Where is M3? Can you see M3 device? Yeah, M3 is this. The question is, find the output impedance at the drain of this device. So for clarity, yeah, this is M3. I'll give you 2 minutes of time just to identify what is that you are seeing on the screen. I'll just give a hint by marking this as the input. Anyway, one hint is the circuit is not complete. The circuit diagram, what you can see, is not complete. But are you guys able to identify what is given? Can I get answers quickly in the chat? So this circuit is having something what we have discussed so far. Yeah.
So in the circuit, are we using like a cascode for the gain boosting?
Yeah, we are using. Yes, I'm just waiting. You can just put your response in the chat. I'll tell you the answer, the correct answer. Yes, Yashita, you can take half circuit and see the output. Yeah, before analyzing, can you identify that there is a main amplifier and there is an auxiliary amplifier? And if yes, can you tell me what is the main amplifier here and what is the auxiliary amplifier here? Yes, Avinash, I saw your response. You are telling there is a main amplifier which is a differential amplifier with folded amplifier. Sorry, diffam with folded amp with auxiliary amplifier. Can you?
Sorry, sir.
Yeah.
Yes,
What is it?
the
Uh,
main amplifier is a differential amplifier, and the
okay.
auxiliary amplifier is a folded amplifier.
Very good. Very good. That observation is right. Yeah, Amitesh, M2 and 4, M2, 4 and 6 is main. M2, M4 and M6. No, that is not main. 7 is auxiliary amplifier. Yes, 7 is a part of auxiliary amplifier. Yeah, that's all right. You can just put your responses so that I can also understand like how much you got the things what we have discussed. M1 and M2 are main amplifier. Yes, that is main amplifier. 5 and 7 are auxiliary. Yes, that is true. That is right, Ashita. M5 and M7 is auxiliary. Yes. Yeah, thank you for the responses so far. So the very first thing is, how will we identify? So we will identify the main amplifier by just looking at the input transistor. So you can see M1 and M2. Vaishnavi, yes, I saw your response. Akash, yeah, I think I responded. Yes. So M1 and M2 are the input transistors because input signal is directly given to that. And if you see to the top, so after M1, yes, from here something is connected, but still you can see that there is a cascode for the input transistor, which is, that is for M1, M3 is the cascode, and for M2, M4 is the cascode. So I'll just write it here. So I have main amplifier with M1 and M2 are the input pair, right? Also I can identify M3 and M4, they are the cascode for the input pair. I hope that is clear. M3 and M4 are the cascode for the input pair. So in that way, can you tell me which amplifier is this? Because you can see only one part, because after this it is left open, or if it is left blank. So what is the probability, or what amplifier, what op amp is this? Any guess? So at this time we will also identify that M5 and M7 is some auxiliary, and we will forget about auxiliary part now. So what is the main amplifier now? Any response? You have input amplifier? Yes, it is telescopic. So how telescopic? You have an input device, you have a cascode for the input, and rest if you elaborate or if you complete this structure. Okay, let me do that for you. So this is the main stage, right? So from here I need to this is the load and this is the cascode for the load, and this will be the complete structure, and from here you can see that you will get the output. I hope that is clear now. So regarding main amplifier, whatever we have mentioned is right. Now let us come to this structure and see what an auxiliary amplifier is used here. See, a signal is sensed from the source of the cascode transistor, and it is given to an amplifier and it is fed back to the gate of the same transistor. That means you have an auxiliary amplifier. And what is the auxiliary amplifier here? I'll write it here. Your auxiliary amplifier is, the transistors are M5 and M7, also with suitable, yeah, let me mark this as I0 current source. M5 and M7 are the transistors there with I1 and I0 as the current source. That should be replaced with a suitable transistors again. Now, can you tell me what is the type of this auxiliary amplifier? M5 is input, then you can see M7. Yeah, as I think you people guessed it as a folded cascode, right? Can you think it as a folded cascode? Yes, Yashita, it is a folded cascode. The only difference is it is a folded cascode amplifier, but the input is a PMOS. So folded cascode with a PMOS input. That is your auxiliary amplifier. All right. So now how will I identify this as a folded cascode? Because the input is given to one transistor. From there you have opposite type as M7. That means folding has done. Then it is you have the additional current source here, and the top you have the current source. That means you have to replace with suitable number of transistors now. All right. So what I will do now is, the question asked is calculate the output impedance at the drain of M3. So this is the point where I need to find the output impedance. So anyway, you can forget about the upper half of the telescopic, because that will be same as, yes Akash, it is P type folded cascode. Yes. Now you are asked to find the impedance at the drain of M3, and the same impedance will be seen to the top. So I am just leaving it again. To the top also you will have a folded cascode amplifier as a folded cascode amplifier as an auxiliary amplifier. How? After sensing the signal from the source of this, feeding it back to the gate, there should be a folded cascode, but that part is not given in this diagram. I'm just leaving it. But now I am drawing your attention to the main amplifier. Okay. Again, we have, so when I'm doing, before doing that, let me also look at the half circuit path. What is a half circuit? So if I'm analyzing, this is, since this is a differential amplifier, if I'm analyzing using half circuit, I can say that this node is at the point of line of symmetry. So that node will be automatically at ground. Similarly, this point is also at line of symmetry. So that node will also be connected to ground. Those two things I can consider as of now. All right, I hope that is also clear. Now I am just drawing the input, the telescopic part, which is M3, and you have M1, but the source of M1 is connected to ground because of the half circuit analysis. Now I have M1 here and M3 here, and this is the point where I need to find the output impedance R out. Is this clear? Are you guys following me? Can I get your response in the chat? Can I get your response in the chat? All right, yeah. Now what you're seeing on the screen as in blue color is the main amplifier, and I'm just marking this point. You can see there is a point marked here as X, right? I'm marking that point here also as X. Now I need to keep the folded cascode transistors here, so I'll just use a different color. So from where folded cascode amplifier input is going, from this X point, it is going to M5, It is going to M5. Now this is M5. But what about the source of M5? Source of M5 is connected to ground because that is coming in the line of symmetry. So I am just grounding it. Now from the drain of M5, you have another transistor I0 to ground. So I am just keeping a transistor there just to find the impedance. I am just keeping a transistor. So I0 transistor, I am keeping a number as M9. So this is M9 transistor. This is suitably biased VB. Now from there I have the folded transistor which is of NMOS type. So that is number 7. So this is M7 again with VB. And you can also see that at the drain of M7, that is this point, should come back to M3. So this should come back to M3 like this. And what is on the top? On the top you have I1 as a single current source, but when you replace this with transistors, you have to replace two transistors here because you know that in folded cascode you have an input and a cascode. So similarly you will have a load and a cascode transistor. I'm just numbering it as M13 and M11 with some bias voltages here. Now you will be wondering why I have included the transistor. If I want to find the gain of this amplifier, the folded type amplifier, I need to replace it with suitable number of transistors there. Now can you identify this as a folded cascode op-amp one side or the half circuit of a folded cascode op-amp? M5 is the input, M7 is the folded version of, sorry, the cascode which is folded, then M11 and M13 are the actual current source. This side is grounded. Is this clear? Are you guys following this? Still you have doubts? Alright, so if you have doubt, I'll discuss now. I'll quickly tell what to do now. So now I have one more point here. Let me mark it as some point P. Now what I need to find here, I need to find the output impedance from this point. So how will I find the output impedance at that point? Let me write what is R out. How can I write R out? As per the discussion what I made for the gain boosting technique, I can write it as GM3 R03 into R01 into A. What is A? A is the gain of the folded cascode amplifier, or I can say what is A? A is the gain from point X to point P. When I will not say point, it is node X to node P, because this is the point where the signal is sensed and this is the point where the signal is given back. So between X and P there is an amplification happening. That is what is marked as A, right? Now how will I write A? A can be written as GM of the folded the auxiliary amplifier into R out of the auxiliary amplifier. I'm just marking it as R out dash just to differentiate between the R out of the input the main stage and the auxiliary stage, right? Now what is R out dash? How can I write R out dash? R out dash is this point, the point P, right, where there is an upper the resistance up and resistance down. So I'll mark R out dash as R up parallel to R down. Where R up is very easy. What is R up here? R up is I have transistor R013 which is magnified by the cascode version GM11 into R011, that is R up. What is R down? Yeah, R down is when I see down there is M7, but at the source of M7 there is R03, R09 and R05, both are in parallel. So I can write R05 parallel to R09 which is magnified by GM7 R07. Alright. Now if you substitute what is R up and R down here, you will get R out dash. Substitute that R out dash in A and your GM is equal to GM5 because that is the input transistor, and substitute the entire A back to R out. You will get the final output impedance at the drain of M3. Alright, so I know that this is a little lengthy. I have explained it, but if you have any questions now you can ask. We have 3 more minutes left. So I'm just winding up today's session. If you have questions you can ask, we'll discuss now. Thank you.